Friends, welcome to my new YouTube video on auto engine cycle. I, Mr. Ajit Ghatge, lecturer of Mechanical Department, KLE CV Polytechnic, Chikkodi. Dear friends, today we are going to discuss about auto engine cycle, or simply you can say ideal auto cycle. So in this cycle, there are 4 different processes. And in this, heat is received and rejected at constant volume. Therefore, it is also called constant volume cycle. Means, in this cycle, the heat is received or heat is rejected at constant volume. That's why this cycle is also called constant volume cycle. And in this, 4 different processes, 2 constant volume and 2 reversible adiabatic or isentropic processes. Let me explain each process. So in this diagram, we can say 1 to 2. Here, this is process number 1, that is called isentropic expansion. So in this process, the air is expanded reversibly and adiabatically from temperature T1 to T2. See here, temperature T1 to T2 means drop in temperature, means decrease in temperature, means from temperature T1 to T2, decrease in temperature and increase in volume and decrease in pressure. So in this process, what happened? Temperature decrease from T1 to T2, volume increase from V1 to V2, and pressure decrease from P1 to P2 here. This is process number 1, and in this no heat is absorbed or rejected, means in this process there is no supply of heat or rejection of heat, means heat remain constant but temperature decrease, pressure decrease and volume increased. This is process number 1, that is called isentropic expansion process. Then process number 2, from 2 to 3. In this process, volume remain constant, temperature decrease from T2 to T3 here, pressure decrease from P2 to P3, but volume remain constant and heat is rejected in this process. When volume is constant, at that time heat is rejected from system to atmosphere. This is called what? Constant volume cooling process. What? Constant volume cooling process. Means temperature decrease from T2 to T3 and heat is rejected by the system or by the air to the atmosphere. Now, heat rejected Q equals to what I can write? Q equals to mass of system or gas, mCV means constant volume, into T2 minus T3. This is the what? Amount of heat rejected from system to atmosphere. Now, process number 3, that is called adiabatic compression process or isentropic compression process, means from 3 to 4. So in this process, temperature is increased from T3 to T4, volume decrease from V3 to V4 and pressure increased from P3 to P4, and in this heat remain constant. There is no addition or rejection of heat from the system or by the system. But in this process, temperature decrease from T3 to T4, temperature increase from T3 to T4, means here temperature increased due to compression, and volume decrease from V3 to V4, and due to compression, pressure also increase from P3 to P4, this much. And in this, heat is remain constant, but simply temperature and pressure increased and volume decreased. This is called adiabatic compression, or can say isentropic compression process, third process. And last is constant volume heating, fourth one, that is from 4 to 1. In this process, heat is supplied, means temperature increase from T4 to T1, this much amount of temperature increased, and volume remain constant, that is V1 equal to V4, and pressure increased from P4 to P1, this much pressure. And in this process, heat is supplied from the external source to the system, means heat is supplied to the air from external source. Clear? Next, I can write amount of heat supplied Q equals to mass of gas, mass at constant volume Cv into T1 minus T4. This is the amount of heat supplied to the system. This is the process number 4th, means from 4 to 1. In this process, volume remain constant, pressure increased from P4 to P1, temperature increased at constant volume from T4 to T1, this much, and heat is supplied from external source. This is called process 4th, constant volume heating. This is working principle of Otto engine cycle. So you can see here explanation of this Otto cycle process. This is the amount of heat rejection in second process, Q equal to mCv of T2 minus T3, and this is amount of heat supplied to system, Q equals to mCv of T1 minus T4. And in first stage and in third stage, heat remain constant. That's why there is no supply or rejection of heat from the system. And in this cycle, heat is supplied or rejected when volume remain constant. That's why this is called constant volume cycle. So here HS means heat supplied, HR means heat rejection, isentropic expansion, isentropic compression, and this is not pressure, this is temperature. There is a correction, temperature. See, this is called Otto engine cycle. Thank you for watching this video.